Our database concepts help us understand how to organize data and structure it in a way that makes it simple to access. Here are the database concepts that we're going to be talking about in this video. We're going to be covering what tables, records, and fields are. We'll be talking about primary keys, queries and reports, schemas, multi-user access or access to databases, cloud and local databases, as well as overall database access. Let's start here with cloud and local databases. So our databases can be stored either locally on a computer or server or out in the cloud. The main difference is where the data is actually stored and how it's accessed. So cloud databases, pretty simple. They're hosted on the internet. They're accessible from anywhere where we have the right permissions, login, and an internet connection. They're quite scalable, meaning that we can move resources up or down for that database as needed. In terms of maintenance, the maintenance on the actual server that's hosting the database is done by the cloud provider, but we actually still need to do the maintenance of working with the data. So even if we use a cloud database, we still have to be the ones who manage that data. In terms of local databases, these are usually, again, stored on on-site computers or servers. They're limited to local networks or locations or specific company resource. They're limited by hardware, and they often do require a lot more backups because we have to actually store that data. Usually, for the most part, cloud databases can help us automatically take backups, but for local databases, that's our priority, or that's our responsibility rather. And we also have to worry about a lot more maintenance on the actual servers that are hosting those databases. Now, whether we use a cloud database or a local database, we are still the ones who are managing that data. So very, very rarely will a cloud database actually be managed by someone else natively. Usually, again, we manage the data and the information for both our cloud and our local databases. Here we have tables, records, and fields, and these are the main parts of a database that help us organize and store data clearly and logically. Our tables usually store related information. Records represent individual entries, and fields hold specific types of data so that information can be easily connected and managed across multiple different tables. So tables, collection of related data, they store related information in one place. An example might be a student table. Records, single row in a table, represent one entry. An example here would be one student or one course. Fields is a single column in a table. So fields, again, they're part of a table. They store one type of data. And an example could be the one type of data being a name, ID, an email, phone, address, things like that. Here's an example of a database diagram. Here, this is our table, and we have different columns and rows that store information. For example, here in this ID column, this stores the ID. So 1, 2, 3, 4, 5, 6 belongs to the name of John, and John's email is john@example.com. ID number, let's say 901234, that belongs to Mary, and Mary's email is here. So you can see databases, they store information, and they're rather simple in table format. A schema is the actual structure, blueprint, or high-level overview of a database. They control different things like tables, fields, and relationships, and how our data is stored and accessed. So schemas protect sensitive information by controlling who can view or change information through permissions and rights and roles. They also help keep data organized. They limit access to only what users need, improving security and privacy using the concept of least privilege. We'll talk about least privilege in the next section on security, but just keep in mind schemas can help us with least privilege and implementing that on databases. And lastly, they help our database run efficiently and reliably by keeping things structured and consistent. Here's some examples of schemas. So we have a course schema here with a course table and some different types of course data here. And here we have a section schema for a section, and then we have student for student schema. A primary key is a very, very common and misunderstood topic in databases. A primary key is a field or a combination of fields used to identify each record in a database. It helps us make sure every record is different from others. Here's a picture in an image of a primary key. So primary key helps us link data between tables, keeps records organized and easy to find, and a primary key must be unique. So no two records can have the same value. It also can't be blank. Every record for a primary key has to have a value. Here's an example of a primary key. In the example of student details here, this column here, or roll number, is the primary key. Then we have name as well as marks or grades. And the reason why this is the primary key is because this data stays consistent. No matter what happens in this database or what happens with the student, they're always going to be assigned this static roll number. So for example, we might have someone named Mark has 101, Sue has 102, and Jack has 103. No matter what happens, this number is never going to be recycled to someone else. So if Mark stays here, it's always going to be 101. If he leaves, that's always going to be 101, even if he's inactive in that database. While name can change. So if Mark has a name change, or if Sue has a last name change, she gets married and she takes on her husband's last name, the name is possible to change. Same thing with marks. Marks can change as well. These are our grades. Marks can go up, they can go down, they can change. They're not always going to be permanent or static. But this is the primary key in this table because this is the information that's remaining stable and will not change. Next up is queries and reports, and these are tools used to retrieve and display information, and reports can also help us make sense of information. So queries help find specific data. Think of queries like a search or search term. You can go on Google, you could search for specific things. That's kind of what a query is. It's searching for specific information or specific data. Reports, on the other hand, actually organize that data into very clear and readable formats that we can review and use for decision making. At that point, a report would contain information, not necessarily just data. So queries, again, they're used to search. We would do a query on a database, find the information or data we need, and then we would compile that information and data into a report that anyone could then go and read. It would usually be in a very simple format, and it would be very, very summarized. So that way someone can easily view it, they can see it, they can understand it, and then they can use it for whatever use case they have for that information. Let's talk about access next, because access to our databases needs to be guarded. Let's talk about multi-user access. Now, this isn't really on the security side of things. This is more on the access side of things, meaning how people can edit the database. So a multi-user access is a feature that allows more than one person to use a database at the same time. So for example, you could have 4 people working on the same database, working with the same data at the exact same time without necessarily needing to have only one person editing things at a time. The database updates in real time. So if one person makes a change, everyone else can immediately see it while they're working. While not database software, some common examples of multi-user access that you probably know about are Google Docs, Google Sheets, Google Slides, things of that nature. If you think about it, Google Docs has a huge advantage over Microsoft Word because Google Docs allows multiple people to edit one file at any time. In a Google Doc, you could have 25 people working on the same document, and the document updates in real time, so everyone can see the changes. Meanwhile, in Word, at least on a local version of Word, you can't do that. You have to pass the file around. So for example, if I make the edits, then I have to pass it to someone else, and then they have to pass it to someone else. It makes things way, way harder if multi-user access is not enabled on a program as far as productivity. And that's why many databases use multi-user access. But just keep in mind, if you ever get stumped, just remember programs like Google Docs, Sheets, Slides, ones where you can have real-time collaboration. Next up is the actual ensuring of user access. So this means making sure that users can access data when they need to, and only that data and no more. It's focused on the rights and permissions required for our databases, and it allows employees to do their work to access resources when needed. It also ensures that critical or sensitive data is available only to those who need it. So an important note here, principle of least privilege is essentially a principle in cybersecurity where we only give the most amount of permissions based on their job duty and what they require to actually do their job. So it's called least privilege, and I know I just said more. So let's go back a little bit. An important note here, principle of least privilege is giving someone the least amount of access, rights, or roles in order to access the information that they need. For example, if you have a CEO, he doesn't necessarily need to have access to IT roles. He doesn't need super system administrator, system administrator. He really doesn't need access to the different types of routers and VPNs and switches on a site. We would give even the CEO the least amount of rights possible for him to do his job. That's incredibly important, and we're going to cover this a lot more in the cybersecurity section, but just keep in mind, even for databases, we ensure that we're giving the least amount of access or privileges to everyone, no matter who the user is, from a janitor to an IT technician, to an accountant, to a lawyer, a corporate lawyer, to someone in HR, to even the CEO or C-suite executives. We give people the least amount of privileges for their job role. So every job role will have different permissions and rights and access, and that applies to databases as well. And that's it for this video. In this one, we covered all about multiple different database concepts. These concepts are crucial for understanding how to use databases, how to get information through querying and then turning that into reports, as well as ensuring that we have the proper access set up for our databases.